Number 32. It says triangle QRS is graphed on the set of axes below, and then it's asking us to do on the same set of axes, graph and label triangle Q prime, R prime, S prime, the image of triangle QRS after a dilation with a scale factor of 3/2 centered at the origin. So there are many ways of doing it. You can count the boxes and all that stuff, but I like to do it by the rule. The rule is, which I wrote it here and I'm going to highlight it. When centered at the origin, multiply coordinates by the scale factors. So if I pick all my coordinates of Q, R, and S and I multiply them by the scale factor, I can get my new coordinates. So I'm multiplying 3/2 by each of the coordinates. So -2 times 3/2, you can put that in your calculator, or you can do some mental math, is what? -3. And then 2 times 3/2 is 3. Similarly, R prime would be 3, 0, and S prime would be 6, comma 9. And I'm going to plot those. So -3, 3 is here, and then 3, 0 is here, and we're going to label them also. This is R prime, Q prime, and then this is my S prime, right? And I can just use my freehand, or if you have a ruler, and that is my triangle, right? So okay, so it's saying use slopes to explain why Q prime R prime is parallel to QR. So we can basically find the slopes of these two lines, and what do we know about parallel lines? They should have the same slope. So let's find the slope of QR. Look at this, the line's going down, and it is what? It's going down 2 over 4. So the slope of QR is -2/4, and if you simplify it is -1/2. And let's find the slope of Q prime R prime. It is going down 3 units. Since it's going down, it's -3/6. You can count that, and that also simplifies to -1/2. So now what can I say? They both have same slopes, right? Same slopes. Therefore, these 3 dots mean therefore Q prime R prime is parallel to segment QR.